Hello, and welcome to Reformulate AI. In this video, we will teach you everything you need to know about how to use Milvus. Before you can work with Milvus, you need to have a Milvus database instance installed and deployed. You can install Milvus using Docker or other methods. For more information on how to install Milvus, check out our video, How to Install Milvus. The easiest way to start working with Milvus is by using the official Python SDK, PyMilvus. In this example code, we are importing the NumPy Python package to help work with vector data as arrays, then we are importing several objects and utility methods from the PyMilvus Python package. These methods will allow us to easily connect to a Milvus database to interact with it programmatically. To connect to an existing Milvus database, simply call connections.connect, passing in the host URL and port information for your database. The default port to connect via the Python SDK is port 19530. If you have multiple databases, you can also specify a connection alias string for the specific database you are connecting to. The default connection alias is the string default. Alternatively, if you are trying to connect to a Milvus Lite instance instead of a dedicated Milvus cluster, there is some additional code required. Before calling the connect method, first import default server from Milvus and call default server.start. Then you can introspect your local Milvus Lite server's port value using the default server listen port member variable. Now that we are connected to a Milvus database instance, we can create a new collection. A collection is a group of vectors and corresponding metadata with a shared schema, similar to a table in a traditional relational database. First, we define a list of fields, each with a field schema that defines the field's name, data type, and other attributes. For example, we can create a primary key field with an auto-incrementing ID or set auto-ID to false if we want to specify our own primary key. You are required to create a primary key for each collection of either data type varchar or int64. Other supported data types include double and float vector, which is a special type used to specify vector embedding fields. Each vector uploaded must have a fixed shape which is predefined using the dim attribute as part of the field schema. A group of field schemas can then be combined into a collection schema. Finally, the new collection is created by instantiating the collection object while passing in a collection name, collection schema, and any other optional collection level parameters you would like to set. For this example, we created a collection with 3 fields, pk, random, and embeddings. The primary key field is named pk, and it is a string variable of type varchar which we must include with each vector we upload. It is important that each pk you upload is unique, because Milvus does not yet support duplicate pk validation or unique key constraints. If you upload multiple vectors with the same primary key, results at query time will be inconsistent. We also create an additional scalar metadata field which we name random. This will store a random floating point number we generate along with each vector. Finally, we created a field named embeddings to store our vector embedding. For this collection, all vectors will be arrays with 8 floating point values. To perform efficient vector similarity searches, you will need to create a special index on your vector field. Milvus supports many different types of vector indexes. For this example, we will define a new index of type IVF flat, which allows for a very high recall rate at search time. You can also specify additional information like the default search metric or other index-specific parameters. To create the index and index any existing data, call the createIndex function, passing in the name of the vector field to index. The combination of vectors and corresponding metadata are referred to as entities in Milvus. To upload data to your Milvus database, first organize your data into a list of lists, where each list corresponds to one of the fields in your collection schema. All lists should have the same length. For this example, we will use NumPy to generate random values for all of our data. Then simply call the insert method of your collection object, passing in your entity data. Before you can search your collection, the collection index data needs to be loaded into memory. This allows for efficient vector similarity search. If you forget to call the load function, you will get an error when you try to perform a search against that collection. To perform a vector similarity search against the data you uploaded, call the search function, first passing in a list of 1 or more vectors to search. Additionally, you must provide the name of the vector field to search against, search parameters specific to your index type, and how many of the top k similar results to return. You can also provide additional optional parameters like a list of fields to return in the search results if you don't need all the fields returned. The search will return a result object that contains a nested list of hid objects for each of the query vectors you specified. Each individual hid object will contain the primary ID for the similar vector, a distance value representing how similar the vector is to the corresponding query vector, and any additional entity metadata you choose to return. One powerful feature of Milvus is the ability to easily perform a hybrid search which runs a vector similarity search after first filtering on scalar values saved in the entity metadata fields. This is accomplished by adding an additional search parameter, expr, which is a Boolean expression used to filter on a scalar field. In this example, we are first filtering to only entities where the field random is greater than 0.5, then performing a similarity search against all vectors that remain after applying the filter. As a vector database, Milvus supports create, read, update, and delete operations similar to a traditional relational database. For example, to delete vectors from the database which are no longer needed, specify a list or Boolean expression which contains the primary keys to delete, and call the delete function. Thanks for watching. If you have any questions, please leave a comment below or visit our website at reformulate.ai for more content.